So, have you ever stopped to think about how a modern software engineer is actually made? It's kind of like building a skyscraper, you know? You can't just start throwing up walls. You need a rock-solid blueprint, a top-notch workshop, and, well, a secret ingredient that brings it all together. Today, we're going to tear down that entire process and see what makes it tick.
Okay, before we get into the how, just look at what students are building. Right off the bat, a neural network that can spot fake news with over 93% accuracy. I mean, come on, that's not just a homework assignment. That's taking on one of the biggest problems on the internet today.
Or what about this? Using complex neural networks to literally paint with algorithms, taking the style of one image and applying it to the content of another. This is that perfect sweet spot where deep technical chops meet pure, unadulterated creativity. And it's not all just flashy AI. We're also seeing this incredibly solid foundational stuff, a whole multi-user file management system built from scratch. We're talking threads, socket programming, the core nuts and bolts needed to handle tons of users at once, keeping all that data safe and sound. And then there's the stuff with huge real-world impact, using a machine learning model to predict who's going to default on a loan, and then actually deploying it as a web app. I mean, this is straight-up data science in action.
So you see these incredible projects, and the question just hits you, right? How? How does a student go from sitting in a lecture hall to actually building this stuff? That gap can feel like a chasm. So what's the bridge? That's the billion-dollar question we're digging into.
All right, part one. It all starts with the plan. A really, really good plan. We're calling this the blueprint. This is the national-level game plan that makes sure every single engineering student is starting from the same powerful foundation.
See, this isn't just left to chance. In a country like Pakistan, the Higher Education Commission, the HEC, lays down a standardized curriculum for every single computing degree. This is huge. It guarantees a baseline of quality, and it also means their degrees are recognized internationally, which is a massive advantage for graduates. And this blueprint doesn't just appear out of thin air. It is a carefully, meticulously built thing. You've got a committee that brings together the best minds from universities, from the tech industry, and from R&D labs. They draft something up, then they send it out for feedback, not just locally, but to experts all over the world. Then they revise it. It's a whole process designed to keep the education both super rigorous and totally relevant to the real world.
And here's what that blueprint actually looks like on paper. Look at where a student's time goes. A whopping 38% is dedicated to the computing core. That's the non-negotiable, foundational knowledge. Then you layer on another 29% for software engineering specifics. What you're building is what they call a T-shaped professional. They have a broad understanding of the whole field, but they go incredibly deep in their specialty.
Okay, so a blueprint is just a piece of paper, right? To turn it into a real engineer, you need a workshop. You need a place with the right tools, the right people, and the right culture. And that, my friends, is the university. And we're looking at one of the best workshops around, Pakistan's National University of Sciences and Technology, or NUST. This is where that national blueprint gets taken to the next level. It's where the theory on the page meets the fire of creation, and where raw talent gets hammered and shaped into a highly skilled professional.
And you can really feel their ambition when you read their own words. They're not just trying to check boxes on the national curriculum. They're talking about a paradigm shift, a progressive vision. It's all about building a culture of forward-thinking innovation, not just, classroom instruction.
And the results that come out of this workshop? Well, they really do speak for themselves. The variety is just wild. 1 minute students are building e-commerce websites, the next they're building AI prediction engines, or entire freelancing platforms, or even video games. They're not just learning to code, they're learning to build anything. So we've got the blueprint, and we've got the workshop. But there is one more essential element. This is the secret sauce. This is the teaching philosophy that really ignites the whole process, turning rote learning into true creative innovation.
It's called challenge-based learning, CBL for short. And let me tell you, this is not your parents' lecture and exam style of school. The whole idea here is to start with a big, messy, real-world idea, and then challenge students to build a real, tangible solution for it. It's learning by doing, but on steroids.
So how does this actually work? It's a pretty elegant process. You start with a big idea, something broad and important. Then the students themselves frame an essential question to make it personal. That leads directly to the challenge, a clear call to action. From there, it's all about building it, getting it into the hands of real users, and then refining it based on their feedback. It's the complete journey from a spark of an idea to real-world impact.
So, the big question is, does this secret sauce actually work? Well, the data is pretty jaw-dropping. In a study on this, students were asked if they enjoyed their creative team projects. Before CBL, only about 36% said yes. After, that number shot up to 89%. That's not just a small improvement. That tells you this is a fundamentally more engaging, more exciting, and more satisfying way to learn. Okay, so let's put all the pieces back together. When you want to build a modern engineer, it's not one single thing. It's a perfect combination of these three elements: the blueprint, the workshop, and the secret sauce. It's this beautiful synergy. You start with the solid blueprint from the national curriculum, which ensures everyone has the core skills. You bring that blueprint into an elite workshop like NUST, which provides the environment and the ambitious culture. And then you pour in the secret sauce, challenge-based learning, which transforms students from just learners into active, creative innovators. And this leaves us with a really fascinating question to chew on, especially now. With AI getting so good at writing code and automating development, what part of this educational journey is going to be the most important in the future? Is it the foundational knowledge from the blueprint, the top-tier resources of the workshop, or is it the creative, problem-solving mindset that you can't just automate away? I'll let you think about that one.